Good afternoon, thrill seekers. Are you looking for an adventure? Are you at least 1 meter tall? Are you in good health and have no heart conditions? Then please take a seat, fasten your seatbelts, and we will take you on a ride through OpenRCT2 and its architecture. Please stay seated at all times and keep your hands inside the vehicle. But most importantly, enjoy the ride. I am sure many of you have either played or know the theme park simulation game Rollercoaster Tycoon, often abbreviated as RCT. We will now show you OpenRCT2, which is an open source re-implementation of the game. If you are familiar with the classic RCT games, then what you're seeing now should be very familiar to you as well. Indeed, OpenRCT2 looks just like the original game. In RCT, the player has to build and manage a theme park. This includes managing things as finances, but also designing and creating roller coasters. The original game was coded in assembly. Back around the year 2000, this had a huge benefit. RCT ran great, even on very mediocre computers. This has probably been one of the causes of RCT becoming such a huge success. You did not need a very expensive computer to play the game. Your parents' old compact in the living room was good enough already. On the other hand, the game being written in assembly has a big disadvantage. It is much more difficult and time consuming to modify the game. That's why the developers of OpenRCT2 first re-engineered the original RCT code and rewrote the game in C++. Besides recreating the original game, the main goals of the project are to expand the game with new features, raise game limits, be cross-platform, and fix bugs which were present in the original game. Some notable examples of new features implemented are multiplayer, autosaving, and fast-forwarding gameplay. OpenRCT2 runs on Windows, macOS, Linux, and even Android. Although OpenRCT2 offers many new features compared to the original game, it aims to preserve the original experience.
We'd like to start off with the architectural pattern of OpenRCT2. The architecture of this system closely resembles the model view controller pattern. The GameLogic component group wraps all the game logic and represents the model of the architecture. It initializes the game world and implements an update function that runs every frame. This function updates all the GameLogic components like guests, rides, and scenarios. The audiovisual component group represents the view. It consists of the drawing, paint, and audio components. It uses the state of the game as input to draw sprites and effects, and the audio component handles the music and the sound effects of the game world. The controller is represented by the user interface component. The interface draws and handles windows and UI elements that the user can see and interact with. Clicking on something in the game opens a window where the user can interact with the object.
As mentioned earlier, OpenRCT2 offers a really important feature which the original game did not. I'm talking about multiplayer. This works just like you would expect. In the main menu, there is this multiplayer button, which launches the server menu. You can either join a server or host a game yourself. Up to 255 players can join a single server. Then, in-game, players can simultaneously work on the park and do all the things that they would normally do in a single-player game. There is a list of players in the server, with details such as how much money each player spent. It's also possible for people to join as a spectator. They can watch, but they cannot perform any of the usual actions. It is also possible to run a so-called headless server, which does not perform any of the graphical renderings, which reduces the overhead required for running a dedicated server. The possibility of running a headless server is an example of how OpenRCT's architecture offers benefits upon the original game. In our interview with Gymnasiast, one of OpenRCT2's core developers, he mentions an important distinction between the architecture of the original game and OpenRCT2. The architecture of the original is mostly procedural and monolithic, while OpenRCT2 is more componentized and more object-oriented. For example, the engine and UI code are separated. This architectural design enables using the engine in a headless server, or for example, to use OpenRCT2's engine for other projects. We'll now take a look at how multiplayer was implemented. An important architectural feature of the original game are game commands. Actions of the player which affect game logic are sent to and handled by a central mechanism. In OpenRCT2, this is replaced by game actions, which are similar in goal but less restrictive. When developing multiplayer support, the OpenRCT2 developers were actually fortunate with the original game incorporating this system of game commands. In order to implement multiplayer, it was not necessary to rewrite big parts of the core code. Rather, game actions are synchronized between clients on a server. A client sends their actions to other players and receives actions performed by other players. This made the development of multiplayer rather straightforward.
So a key goal of the OpenRCT2 project is to preserve the original Rollercoaster Tycoon experience. So that means that players can import their 20-year-old save games. However, the legacy save format poses some serious limitations on the game, and let's look at some examples of these. The maximum size of the map is only 256 by 256 tiles. Now, for some this might be enough, but for others this is way too small. Another limitation is that the maximum amount of rides in the park is 256, which sounds like a lot. Walibi Holland only has 35 different rides, so what's the big deal? The thing is, a ride in OpenRCT2 includes not only attractions, but also food stands, kiosks, and other shops. You can see how this can become a problem when trying to build a large theme park. Now, why do these limitations exist? Well, there are two causes for this. First, some game structures only allow 1 or 2 bytes for indexing. Let's look at an example. A park maintains a list of rides, where for instance the first entry represents the park's monorail, and the second entry is a balloon shop. A ride has a single unsigned integer for its index, so the maximum size of the list is 256 entries. Second, the space allocated for game structures is fixed in the memory of the original game. In one of our interviews with the developers, Duncan's Pumpkin mentioned that loading and saving in RCT2 was basically copying a file into memory and vice versa. OpenRCT2 is in the process of introducing a new save format, which will raise the mentioned limitations by, for instance, moving to larger integer types.
Assembly is fun, said no one ever, yet the original Rollercoaster Tycoon 2 was written entirely in x86 assembly code. The OpenRCT2 project is written in C++, so people that are not Chris Sawyer could actually contribute to it. The OpenRCT2 developers use decompilers to implement the RCT2 subroutines one by one as separate C functions. What does that look like? Well, it looks like this. After they had implemented the whole game and RCT2 no longer required to be in memory, they gained the ability to change memory layout and slowly move to C++. However, most of the code still resembles the C implementation. This origin in reverse engineering is still the biggest cause of technical debt in the project, and it manifests itself in the following ways. Assembly code is not exactly readable, so it's not clear what each piece of code in the original game actually does. This causes function names like this and comments like this. This makes working on a project a challenge if you happen to have a change that requires updating that piece of code. Assembly obviously has no support for objects and classes, and we already mentioned that RCT2 subroutines were just converted to C one by one. This means the original implementation of OpenRCT2 consisted of some huge files of mostly related functions that barely leveraged object-oriented features of C++. The result of this can still be seen in the file size of some of the components. For example, the file that contains the game logic of the rides contains 7,823 lines of code. This also makes it hard to find a piece of code you need if you want to implement a change. The only inheritance found in OpenRCT2 is the inherited limitations of the original game. Due to the data structures used in the game and the static amount of bytes available for indexing, the amount of occurrences of in-game elements is limited. The new save format is being implemented as a fix for most limitations.